Here we go. Hello everybody. This camera is a little bit too far off. How are you guys? People? Yeah. Hey ho. Oh, I didn't announce it really this stream, and we have a small group of the people that actually subscribed either to the trash channel or in Discord. And today we can focus on debugging the problems that we got with the VGA. Here's one of those boards, the VGA madness boards that we got. So we experienced, as a short update, it worked, the code worked, and we can address, or we can control, like here, these are 4 projectors, 2 more are on the on the floor. We can output like 6 monochrome images, or many, like 2 or 3-bit color images, even more with lower resolutions, with some configuration of the pins. And what we experienced is, usually what we are doing is we're using the GPIO matrix to send one signal, so 1 bit pixel on off, to each of the color channels of VGA. So it's either white or black. But what we experience is with only in the case that we have like fast oscillations in the pixels. So what I was doing is a random dithering, and in this case we saw a charging of the green channel. So we got like the background was completely green, increasingly green, with each line where we had this random pixels. And as soon the pixels turned off, the green level lowered again. So, and this is something that we weren't able to explain it there. And I think this is some kind of electrical or hardware issue. And we saw this. We didn't see it on the first VGA port, but on the others. And we had some doubters who claim it's software, but we will debug this in detail today. I'd need to force YouTube back to higher resolution. Yeah, I hope we have like, YouTube is complaining that I'm streaming with 25 kilobits per second. Oh wait, no, 25 megabits. Yeah. Am I? What? It's actually showing that I'm streaming with. I can share the screen. I can't even upload with that speed because I have only 20 megabit upload speed. Here's this. This is this screen, and it shows here. So actually, it can't be. That's not. I don't know. I think I set like 10 megabits upload speed. However, every camera is working today. Oops, this is the wrong one. Screen capture. Every camera is miraculously working today. So this is the actual cable that didn't work. I don't know, plugged it in, out and in today, and it simply worked. As does, oh, we have even 5 streams today. So we have the fondue cam, which is here. This is the fondue cam. It's not turned on yet, so the cheese isn't melted yet. These are the breadcrumbs that that were remaining from last time, but I did a special trick. I put a chunk of butter in a pan and fried them a little bit so they are like nice and buttery and good. So we can use it for a new batch of fondue today. This is that, and I got some extra Kirschwasser, so additional juice for the fondue, since I'm not on paracetamol today. I'm feeling fine, for the people who ask. Everything is alright. I was like, everything is good, and yeah, I got another stream. I reactivated my old grabber. Turn off my face here. So, oh yeah, that are some sketches of. This is my tablet, and I can use it to sketch stuff. So, let me create new sketch. I'll save. I think it's discarded. And I can maybe sketch stuff. So, and this is like connected over USB-C to my tablet. It's the Samsung tablet with a stylus, and I'm using like my old capture card as an additional source with HDMI to do this. So we can maybe use an additional thing today. And back to my face. Yeah, croutons. It's croutons. No garlic though. Oh, you have your vaccine strong reaction today. Okay. How are you feeling, Johnny? Did you have like AstraZeneca or which one? Armhouse, Pfizer, yeah. It's like the good. A strong reaction isn't bad. It's good. What is your favorite soldering iron? Okay, so this is a topic I am using, like not a very common. What's the name? XY-tronic RLF to 2000. You can't buy it anymore. It is a 100 watt soldering iron, but recently it started to I think it's the thermistor in my tip started to bug out. I don't know what the problem is. Basically I have like it's jumps around with the temperature, and the station shows an error, so I can still use it for like a few seconds, but then it's starting bugging out, and I need to turn it off and on again. So I will have to replace my soldering iron soon, and I take any suggestions. So what are your Johnny, I take your suggestion for. Oh, Quinn got his new boards on sale. Pine 64 Pinect. Let me take a look at this. What's this? No, that's not a soldering iron. I need suggestions for good soldering irons. And Johnny is my favorite source of recommendations for that stuff. Johnny, you led me through the selection of the components for the microscope. I went the same way you did. I'm still about, I think I will give in and replace this heavy stand for an actual actuated arm, because it's like it's taking a lot of space there. I'm partial to peace. Ein paar Bier und dann geht der Schmerz weg. Sorry in English, drink few beers, yeah. You have this one, Vela Tools. I have maybe to talk to them if they want to sponsor anything. Choosing beggar. What? This is so grand! Johnny! Okay. What's so good about it? Okay, it's all in one, is it? Let me share the screen. Here. Pickup, vacuum, air. Oh wow. So you can basically connect any stuff to it. Multifunction. Yeah, no way I will spend so much money on that. So back to my 12,000 euro oscilloscope. Sponsorship deal. No, that doesn't work like that. I don't know. I gave up on being the choosing beggar and contacting companies. I'm not a salesperson or like doesn't work for me. Every time I feel like super cheap when I contact a company, and they basically, the first what they do, they refuse. And I think a company needs to come to my channel and offer stuff, and I then accept or not. Otherwise it won't work. What's that? Miniature electronic repair. Oh, that's huge. Let me share that screen capture. So I hate sponges. I will never use sponges. What do you guys like about sponges? They are basically doomed to dry out at some point, and I'm too lazy to put water on it or whatever. I like these. Maybe I will show it. I like the brass thingies here. That's everything I need. So let me turn on the camera. Maybe I can show the arrow that I did with my, whoops. I take you around here. Oh wow. Zoom out. Okay, so yeah, I don't want a huge station. I like the way I can take things and stack them and put them everywhere, or move them around here, and this is the station. And I think what I can try is if like this thing is broken, I can replace it as well. So there is like this connector. I don't know if you can see it. So the station is still good. It's 100 watts, and it was like 100 euros or 110 euros or something. So, and it served me quite well, as you can imagine, since I have it like for the eternity of my YouTube channel. It's like 7 years now, and I was using it as well with like huge tips here and soldering huge cables and stuff. So I got a few tips. The only thing that I didn't get is a tip with a cup-shaped tip for soldering, like drag soldering. As you can see, the sponge is already done. Where are my I have some replacement sponges from China. These brass things. I can also turn it around. Oh, here it is. That's the error. So you saw it was like, I don't know. It's still hot, but it will cool down now since it's in error mode. Let's turn around. I don't know if we are able to solder anything with that right now. It's still hot. Like we can turn on and off, but I need a replacement now. Not sure what to do. Let me turn this off if I can. Okay. Yeah, no. And what's happening if I pull it out? Oh, okay. Yeah, I think the error is in the tip here. So basically I have to only replace this thing. And since this is discontinued anyways, this one here, the soldering iron here, and I can't get any more tips for that, I will simply replace it probably with a new one. I just have to see. I think they're compatible with the connector here from this company XY. It's an American company, I think. I will try to get like the soldering iron thing here, but then I also have to get new tips probably. Ah, yeah. If Weller wants to sponsor me, that will be okay. I'm not willing to spend like few $100. Just a sprung pin in the connector. No, it's not. Yeah, 100-pound soldering Chinesium rework station. Yeah, but basically, if it works, it works. Sponsorship is selling your soul, by the way. Check out PCBWay. Oh, really? What are they doing? Dustin. Yeah, they paid me once. No. I have to cash in again with them. I have a few, I think. The next one is they won't be happy, PCBWay, since this next sponsorship is obviously JAC PCB. Let me turn on my face again here. So this was JAC PCB, and they won't be happy like with the fact that I do a project with JAC next. No, I don't think it's the connector. I think the thermal couple in the tip is broken. There's probably like a disconnection there electrically, or no, mechanically. It's probably just because I'm not like touching the connector at all, and usually just if I shake it or anything, it doesn't reconnect. Hello, Peter. Oh yeah, bitluni. Let's turn on the fondue here. Let's get it a little bit warm first and then continue with the butter. Oh, this is, by the way, the capture card that I was talking about. So, oh yeah, I can maybe use it here. So I have like USB 3 connecting to a capture card, connecting to a HDMI cable, connecting to a USB 3 to HDMI converter, connecting to USB-C to the tablet here. But it's working. As long as it's working well. Oh damn. Hello, DevPom. Okay. So, as always, I only prepared one thing of all the things that we wanted to do. Let's collect the suggestions that we got for the testing. So we can we do it fancy here. Face. Okay. So what do we want to test? We want to test different VGA boards. Okay, this is the first one that we... Oh, the card stopped working or what? Wait a second. Okay, my contraption stopped working. No! What? It doesn't show anything. Oh no. Okay, so the grabber part is like yeah, different. Oh well, this is the wrong resolution. Yeah, that's the reason why I got the grabber card, because this USB grabber, the USB grabber is a little bit dodgy. Sometimes it's simply stopping to work. Then what next? We can check ports working. Then we need to check oscilloscope. So we need to solder pins or test pins. I should use a smaller pen size here. Okay. And what else do we test? What's the foobar? The foobar is that we get a strange the strange behavior that we have one signal, so 1 bit per pixel, that's sending to all 3 color channels of VGA. And if we have like an very fast noise in the pixel, the green channel charges up and we get like a green background. And then when the pixels are steady again, it cools down again. So something's going on like an analog foobar there. So we need to figure out if it's fixable with on the board. Oh, what we can do, we can maybe add some resistors. Resistor in series. Resistor in series. Oh yeah, that's great. Okay, let me revert that and do a thick pen again. That's too thin. Resistor in series. To prevent maybe some kind of, I don't know, usually you need to terminate signals, and if we don't have like 50 ohms or something, pull down resistors is another try. Oh yeah, pull down. Oh, we need more space here. Pull down. Okay. What else? Capacitors. But how does just hook up yours? How bad is the impedance mismatch? What? Okay, guys. You are asking me what the impedance mismatch is. Okay, I have one question. What is impedance? And how do I match it? Match it with what? Between the channels? Or do I need to have like, I don't know. It worked on a breadboard, who cares? No, we never, did we test it? No. Always says it's a capacitor, but yeah, it's a DevBomb Electronics and Repair says it's a capacitor. Of course it's a capacitor. Okay, that's also my theory, because we have an alternating current and only in this case the green channel charges up. So something's going on there. And it only happens not on all channels and all pins. So either it's internally in the ESP32, or it's on the board, or it's on the display. Oh, test different displays. So different displays. I have 2 more displays that I can test. Oops. So these are things to test. maybe I oh, let me get a bigger okay, so different board. What's the other? Working channels. Pins. What irritates me, it's only on the green channel. So This sounds like it's an issue with the display, actually. So I would probably test it. Sync on green protocol. Sync on green. Oh, wait. Chris, this is... If it's like the ADC, I think you are right, Chris. I think you are right. Let's test different different displays first. So it might be that swapping pins, yeah, we can do that. So I need to cut the lines, but I simply take another VGA display and then, okay, let's test, let's check what the information sync on green. Maybe it takes the green as the reference. So I don't know if it's taking like the actual ground that we connected to the cable, or it's doing something like with the, because the projectors, let me turn on my face again. The projectors that we got, grab one, they support all sorts of things. So we also got like analog signals in here. So there might be a thing that it actually does internally some hocus pocus, and it's the projector that is confused by like the AC signal. Okay, so how does the sync on green? I write it down. Sync on green, exclamation mark, or question mark. I enjoyed that one. How they terminate analog. In the ADC it's magic. Input impedance as would a clock recovery circuit. If it's cheap, it may not be well buffered. Oh, Chris, you're a well-thought man on this stuff. Okay, let me back to our grabber. Let's remove this oscilloscope, and I think the first what things that we do are see check output green. Oops, yeah, it's green. Oh, what? Twitter? What's going on? Hello photo. Or Max? Or how do I call you, Photochromax? I saw someone calling you Max before. So what's your short nickname here? Could it have a digital sync signal superimposed on the green line? Yeah. It's somehow could be the problem. Okay, let me first let's check if the problem is still there. It should be. So let me point the camera back on the screen there. So this and that. Okay. Might be dim at the end, but by the way, the last time I wasn't able to find a power bank and I bought one. This is from Chibo. It's like a supermarket discount thingy, and it's really cool. It's so compact, and it has USB-C and USB-A ports and 5000 milliamps. And now I can use it for testing if I need. Okay, great. VGA board is still there. Let's power it up. We have the board here. Which one is connected? I have no clue. That's a mess. I disconnect everything here. First, let's take this one here. Turn it on. The fans inside of these things seem a little bit rattly. I'm wondering if I can buff the projectors and build in, like replace the internal fan to be a little bit like more silent. Oh, this is a mess. Okay. So let's connect it. I turn off the lights there. Okay, this is the effect. You can see basically you can't see it really, but that's like every second pixel is turned on and off again, so the effect is apparent that after this block is done, we get like the green, and the green is going away slowly. Noctua fans, yeah. Or water cooling. I could water cool it. Okay, I get another screen, so we tested if it's something screen related. Wait a second, I have the screen here. Okay. Power. And let's take the same cable. So we have no difference there. can turn this off and turn this thing on. Oh, yeah, power cable isn't connected. Yeah. Okay. So basically it's the way the ADC is working inside of the projector. Woo! Woo! Hello, Mark. Okay. Now, let me turn off autofocus because it seems to be too dark for that. Whoops. Here. Full moire. Okay, so there is no green there. Focal trip. Fixing up the impedance may fix the output on the projectors. More expensive projectors. Okay, Johnny. You wanted it. I grab a more expensive projector then. And let's see if we got the same problem there. Okay. So we have an Optoma projector there. It's a full HD whatnot, and oh no, it doesn't have VGA. More expensive projector doesn't work because it doesn't have VGA. Sorry. It's a 3D full HD projector. It was expensive once, but now it's not expensive anymore. So yeah, that doesn't work. Okay. So the question, 75 ohms. So Chris, if we simply put 75 ohms in series on the output, it should work. I have already paid for, yeah, you have. It's probably, I think what I paid total for this projector is 400 euros. It might be like 2 years of your donations. Not sure. Okay, so we have different displays is done. Now we can resistor in series. This is what we do next. 75 ohms. So what we try now is to accommodate the deck. Oh no. Okay, this doesn't work with this grabber. And that's bad. Really? It somehow halts all the time. I hate this. Come back, stupid grabber. No, I hate it. I hate you, grabber. No. Okay, forget the grabber. We do face only here. You need the total of 75 ohms. Yeah, but here is what we got. You need the screen capture here. Pew! There is a resistor in there somewhere. IIRC. So we have direct connection between all the color channels with the VGA. So there is no resistance whatsoever. And we just need to put 75 ohms or match it somehow. So how do we match it? Do we measure? Because we don't know what's on the other side of the VGA cable. Or what do we need to match? The resistance between like Simon. So you can probably be an intern if you live close by, but I'm not sure. We need a vaccination first. What is the output impedance of the ESP32 ports? I don't know. Can we Google it? Let me Google it first. So, screen capture. I will Google it. I will say, since we can output, we can set the port to different currents. Oh no, Simon, it's unfortunately not the address that, it's not Darmstadt where I live now. I live like in Fulda, so it's really far. Impedance ESP32. Can we calculate it from the current that the ESP is able to provide, like 40 milliamps or something? Hello, Michael. Oh, yeah, we got yes, VGA is 0.7 volts peak. Really? Do you think okay, do you think we should put in a resistor ladder there? Oh, are we fonduing? Yes, we are. Oh, the fondue is already ready here. Maybe it needs to be a little bit hotter. And I have from my old breadcrumbs, I made some croutons. So let's test it, how good this is with extra butter. So it's a buttery goodness. Oh! 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 This is so good. Smack a resistor in series followed by a pull down. Yeah, that's basically voltage divider. We can do this because we have huge ground planes. Shall we calculate the actual divider that we need? Or someone of you calculate it? $75 ohm termination. Okay, why do we need 350 ohms in series? So guys, help explaining. Let's put this stupid grabber away because it doesn't work. We can still use the tablet, but then I have to switch the grabbers. Oh wow! The other end of the VGA cable has a termination with oh no! And the other end of the cable is 75 ohms. We need to know how the output is being driven to figure out what spec. Can we test it? We can simply like solder something in the series and see if it's working. Ouch! Oh, hot cheese on my hand. $350 in series and watts to ground. Let me check if we have some surface mount stuff that it's a little bit dark, but oh well, we have all the values here. Okay. So 330, 350 I don't have. Yeah, I have 330. Yeah, it's a live stream with fondue cam and such. Okay. 330 in series. We got a few here. Unfortunately, we don't have enough. That's like, we need quite a few of those, but we can test it with this output. Okay, what else do we need? Do we need to pull it down to ground? Oh, nothing to ground. Oh, that's easy. Okay. Let's switch to the microscope then. Pew. Ah. Yeah. Why it's so crusty today? It will be a challenge to solder with this broken soldering iron. And let me grab another chair. So actually we can easily fix the design by putting some additional. Oh, which one did I connect? Was it this one? I think it was this one. I need to test again. Yeah, let me connect it to the projector again, so we are sure we are changing the right one. And this will be almost like enough for today if we can fix that, but we have some stretch goals. I just need to quickly confirm that it's VGA2 is the right channel to fix right now. Oh, wait. No. Which one was it? Oh, VGA3. Yes, okay. Okay. VGA3. So, yeah. This is the one to fix. And this is, oh no. Yeah. Okay. Can we focus? I don't know if we are in focus here. It's almost like this should be in focus. The screen is so far away that I can't tell if it's in focus or not. It's bank holiday today. Yes, it is. I almost missed that because I was in the bakery yesterday, and since I'm like self-employed, or I'm sitting here in the basement basically all day, I never know this if there is a holiday or not. And she wished me a nice holiday, and I just asked, which holiday? So I thought it's a good idea to stream today because you guys probably have some free time. So VGA3, I believe, let me get something to point here. We have like 3 lines going in here, and if we trace them back to the ESP, we can simply put the resistors in series here. Green is probably center, but we need to replace all 3 because I think this is the way like we prevent it from having one signal very high and the others low. I check with the schematic again. We should make him add a transistor. Yeah. Yeah, that would drive my... Yeah, TLDR, someone please do it. It would drive my production costs by another 2 cents. No way this is happening. Okay, let me check. VGA3. This is the board. So where's the screen capture? This is the board VGA3, and we can see BRG3. These are basically connected here, so we are right. We simply need to put them in series here, that's easy job. I just take off the solder mask and grab a screen capture, and we can put the resistors there. Easy peasy. Okay, let me grab a Sharpie. Not Sharpie, X-Acto knife. And you guys enjoy. So the 10 volts that I already have here can't be sold, only for collectors. I would need to like hands fix them. Maybe I should also record on the hard drive for the video how I fix that. Okay, I might use another recording of that. Now we need to cut the trace. Let's go closer. More closer, closer, like that. More light, like that. Okay. Ah. Okay. Blah. Do I have Q-tips? No, I mean... give me a second, I grab some Q-tips. But I got some here. I think I got some. Nice. Let's clean that a little bit. Okay. Got it. It was quite dusty already. Okay, I also need to clean my tip. Now cut. Oops. Okay, yeah, that's a ground plane anyways. The gap doesn't... Okay, so we got... Fortunately, this is only a 2-layer board. I don't know if the view is sharp for you, but it is for me, certainly. So these are basically our new SMD pads. Yeah. Wow. Okay. But actually, I can barely see this with my eyes. I thought this is like a huge gap, but looking at the camera right now here, or in real life, I can barely see it. Okay. You need a size comparison. 06, 03 resistors. We might need to. No, this is 08, 05. Okay, I lied, but that's the only things that I have here. It looks big, but it isn't. So I need to clear a little bit more of the solder mask here. Otherwise we won't be able to. It looks funny, doesn't it? It's like this hot air finish. The new boards that I ordered for another project are all gold plated. JC pays them anyway, so why not just taking. Oh no, I'm not sure. I think, did I take the gold plated? There is a limitation. I think you need to take like some extra costs and delays if you want a non-green gold plated board. So I hope they are able to scale up the production and sell many more boards, so that this won't be an issue in the future. Might even make the gaps bigger. Okay, I will test the continuity now. Cut the pads and use the pad for one side of the resistor. What pads? Oh yeah, yeah. I could. I leave it like that right now. Sorry, it's too late for me. This way I have bigger working area with my tip. It's all good. This is so buttery good. Oh shit! Oh! I have fondue cheese all over the place. Oh. Yeah, I don't have 0402. Actually, I might even have. I don't know. Maybe I can check if I have a different resistor values, but 330. I have 300 ohms. But we need a little bit higher value. I have 300 ohms 0603. If that works as well. But let's keep going with this here. Sync signals? No. Would work as well. Yeah. You think so? Lower might be better. But then we get like a higher voltage, so it's like 1 volt in. No, syncs are TTL, okay. Martin, where do you know this from? Did you read all the specs? Okay. Even I was too lazy and I sold so many VGA boards already. It was just by coincidence that the impedance was matching at my resistor ladder output so far, or at least it was like somewhat okay. Okay, so these are the resistors that we got. They are huge. I need to flip the board, otherwise it will be hard for me to reach it. No, this way is better. Okay. Lost one already. Here it is. Okay. Oh, I wanted to test the continuity first. Where's my meter? Did I use it last time? Huh? It's gone. Okay, I can see it. Where's my meter? It's probably buried underneath all these boxes from the packaging here. Okay, I can find the meter. Let's do it live. Let's just test it and see if it works. Oh wait, I know where it is. It is in my toolbox. I had this last week. Okay, it was in my toolbox because I was on the road 2 weeks ago. So of course I had this with me, and it helped because I was also selling the car of my mother that was sitting there in the garage for the whole winter. And of course the battery was dead. I didn't think about it to cut off the power, and I really needed a multimeter there as well. So it was actually quite handy, and I was able to revive the revive the battery. It was hidden like because it was like a Mercedes. The battery was in the back in the trunk. And I wasn't able to open the door in the back because it was all electrical, or let's say the mechanical keyhole was never used before and was completely like stuck. Okay, continuity testing, and I used like a small, you know, these like super cheap lithium-ion chargers for like hobby things. Okay, this is continuity for that. Okay, no. Okay, and I was able to charge it to a few volts first, or like it was like 10 volts. Then open the hatch and then jump start it with my car at the end. I tried to charge it for hours. It was like, it took like 4 amps all the time. But then I had to jump start it, or at least like recharge it with my cars with 10 amps all the time for half an hour, and at the end it started again. Okay, we might want to use a hot air gun here instead of the soldering iron, because, or do we try it now? Soldering iron is dead. I will take the hot air gun instead. Okay, we need some. Okay, let's turn this on. Oh no, this is like completely stuck here. Use another one. This tip is closed. You're wondering what this is? Flux. Okay, the flux is everywhere else than I needed. Okay. Is this even? It doesn't look like it's. I think the finish is not lead free. Okay, I turn on my soldering iron in the hopes it helps. Okay, we got the error, but it was sufficient to. I need more. No, this isn't working with this stupid tip here. It's like a mess without a working soldering iron. Is it too hot? Ah, no! Yeah, that's good. Tombstoning. Here, and that one is upside down. Just to trigger you all. Oh no, it flipped. Oh shit! Look at the connector! Oh no, I touched it with... Oh no! That's a mess. I try to use the soldering iron. It's like no good at all. Ah. It's like very sticky. How to solder without a working soldering iron. Yeah, turn this off. This is annoying. I hope you guys having fun. This sticks to my tweezers, not to the board. What the? Let me grab another tip. I will try another tip. Finer tip here. No, this is not. Okay. Somehow I'm too far away from this. So much stuff here, but I can't even solder a simple resistor. this closer. Oh, you guys can't even see anything. Sorry. I just need to make sure. Okay. Yeah, not much contrast for you there. I hope this is good enough. This doesn't look like that. I have a little bit more clearance there. Sorry, I'm not able to read the chat right now. Let me take off a little bit more of this here. I think this one is good. Yeah. This, I like it better. Okay. Ah! That's a mess. But really, you can't tell it if you see it on camera. Let me show it here. We can test it, but yeah. Hocus focus. Here, 3 resistors. They look huge on the microscope, but it's really like super tiny, and you wouldn't tell there what a mess it is, and that I have melted the connector here. Okay, let's test this thing. Turn this on. Not taking it apart. Okay, I need to turn off the lights here. Okay, now I'm not sure. Oh, you can see anything. I don't see the green anymore. But I'm not sure how white it is. How can I... Okay, this is like not this... This is like only 50% white. Let's test a full white. Oops! Oh. Maybe we can compare it to... Oh, wait. I turn on another one of those and connect the next one for comparison to see if we get like the full brightness on the signals here. I think we need VGA 1. Oh yeah. This is I'm confused. Two. This is 0. FUF? Oh, I missed so much chat. Put them on their side, yes! Tombstoning. It would be funny, but yeah. Okay, let me check the code. If I can... So we don't have this green effect anymore. It was basically overdriven. Yeah, citation. Okay, this is... Oh, wait. Huh? This is not the code. Oh, this is the wrong one. Okay, let me share the code. Y 400 500. Okay, so it should be on all the lower displays. So it should be also on 4 and 5. So let's... Okay. So the brightness is crap. Here. Obviously, the resistor is too high. We need a middle ground. How about measuring it? Yeah, but how? How do I measure it? Oh, you mean the output? You want the scope? Okay, let's do the scope. But then I need the sync signals. Let me eat first. I need the sync signals, and I will just add a wire there. I will add some wires and we can see both sides of the resistor. Oh, you are right, we need the resistor as well. Just the voltages. But then I need a steady signal, and I don't get this with the VGA. I won't mail you fondue. You have to buy it yourself. Please don't use Arduino ID, it burns my eyes on. I like those substitute resistor kits. I just have to pigtail to solder it in. The maximum, okay, yes. But we need this, oh yeah. Okay, yeah, you are right, that's easy. I totally forgot that this 12,000 euro scope should have a maximum function. Oh, but this fondue is so good. Let me grab this. I have not much left. Maybe I need to get some more bread. Yeah, but it would be really nice to see the actual signal. I'm wondering, one-shot trigger, you guys have to teach me. Oh yeah, it's croutons. Very tasty. Okay, let me solder some wires. The LED projectors are so cool. No cool down phase. Microscope. Beep, beep, beep. I believe we'll be able to debug it quite quickly today. And I won't make it the stream too long, because then we can simply stream more often than today. Oh, this is my botch from the RX and TX. And we have, just in case, I will add some wires to all the, where's my wire kit? I will just solder it to these pins here. I don't want to mess around with the resistors for now. What the heck is my... Eh? Ah, here it is. Okay. I got some colorful wires, RGB or something like that. And we need also ground. Where's the black wire here? Okay, so let's take that first. We need ground, then we need RG and B. Do we need the before and the after? Doesn't it's just we can do the after and see what the resistance is. Okay, we could do the before, but okay, we do the green before, okay? Just for you. I grabbed a few wires here and just remove the isolation. These are the sync signals. Red, blue, okay. Ground first. If I can even melt it here. Not sure. That might be the wrong tip for that here. Quite small and we have a huge ground plane. No chance here. Okay, this is the ground. Now the green. Green should be this one here. Let me check on the schematic. And green is the other one. This is ground here. This is ground, yeah. This is green. My broken soldering iron. No. Error. It's a little bit annoying. Come on. Yeah. Oops. Oh no. Okay. This is good. What is green? This is green. Now we need red is the outer one. Oh no, it's not really like. Okay, better. Oh, I don't like this here. It has one strand. I'll just take it here. Hope it sticks. No, it doesn't. And the orange is cool again. Yeah, I hope you guys like seeing me struggle here with that crap. Okay, blue. Now quick, before it cools down again. No, that doesn't work well. But it's good enough. Where are the sync signals? Whoops. Okay. V-sync and H-sync. Okay. find one more, the extra green, add source. This will be here. It's probably not sharp for you here. It's a better view. Uh-oh. Uh-oh. Ah. Oh, it's cooled again. What are you guys making me do here? No bridge. No bridge. Okay. One more thing. I just need to get at least one wire here, a little bit solder on. Yeah. So it's tinned. Okay, that's good enough. Okay. Are you happy now? Are you happy? Let's take a look. How do we do it? Let's set up this camera again. Not enough RAM for 6 displays. What is not enough RAM? Ah, do I need to? But the divider is, it's not half. Need to download more RAM. Yeah. The RAM is good enough. We can do plenty of stuff with 6 displays. Oh, I have a crazy idea. You guys know what? We can reconfigure the pins. Each line. So imagine we get an interrupt per buffer, per line, and simply can change the configuration from to have any color. That's we can set, like for each pin we can set high or low, or we can invert the signal. So the one bit can get any color that we want. The GPIO configuration allows that. Or at least the matrix configuration. The croutons are delicious. Everything is delicious with enough butter. Yes, I'm sure, Martin. I'm really sure that you can invert. There is a specific parameter configuring the GPIOs, the matrix, where you can say the signal is inverted. This way, this is meant for differential signals. So you could send out like a typical signal and then invert it to get like differential pair. So you actually can invert the signal and you can get like either red or blue for each big pixel or something like that. Then we would do then we need to we need an additional buffer to for each line or each part of the buffer. Any color for foreground and background. Oh man, this is getting crazy. Oh, main camera. Yes, I want to change the main. Sorry, I'm still on the microscope. At least you don't need to see me chewing here or eating like with I put the remaining croutons here and this is like a mess. This is hot. I think this might be hot. Oh, this is so delicious. I love cheese and I love Pong on ESP32. Yes. Visual globe. No, there is nothing like, okay, so Christian, the problem is that we can't do a lookup, because then we have to, okay, we could do it with an interrupt and decode each pixel, but the problem is then we occupy like the complete processor and we don't have. We could do it. I did like on like the first of my the ESP VGA videos, I even did a run length compression to get a complete like foreground background image. So there was even a decoding in the interrupt that said skip like the next pixels and fill it with background or whatever or pattern. So I did something like that. I don't know, but it's like very processor consuming. Just change the sync interrupts. Yes. Okay. Do we want to test it now? Okay. Is this working, this oscilloscope? It seems to be working. Now we need some power. Camera. Pew! Ha! You guys are you are getting spoiled on my channel with all the cameras. And imagine the Blackmagic grabber that I'm using also supports 4K on each of those cameras. The only problem is YouTube. The latency would be so obnoxiously slow. We tried it once. That it's basically not possible to stream and interact live with you guys in 4K 60. Okay, oh yeah, you need to see what I'm doing. Let's get the bare signal here. Okay, this is our signal. This is the green. And what do I do now? Yeah, 1440p. But then it's not a huge difference. I want a full 4K. Would you guys, I thought of buying a 360 camera. Would you use that? But I don't know how to configure it to mix the displays. So it would be hard to get like a 360 with the chat or anything. Look for max value. Okay, max value. But we had some kind of trigger. Didn't we want to trigger something there? No. Okay. Measuring. Add measurement. Type. Maximum. Okay. We have 4.5 volts. Which is basically wrong. How can we get 4.5 volts here? What's the deal? No, it's not. Oh yeah, we get like some kind of what's yeah, that's no display connected. Okay, let's connect the display now. This is like basic. This is the output without any loads. Okay, or impedance or whatever this is called. Okay, let's connect it. Wait, what? The signal vanished. What did I wrong here? What's going on? Uh-oh. Did I short something? No. Okay, signals there. Oh yeah, okay. I don't know what happened, but Okay. It's back, yes. No, I had to reboot the ESP. I don't know what happened there. But why do we see like this here? What's this? It confuses me. Is this the probe? A signal, you likes a signal. Okay. This is 2 volts per division. Yeah, but let me show you the signal that we are actually outputting. So this is before the resistor. Now you get after the resistor. Let me get the second probe connected here. Or if I can find it here. It's dangling here somewhere. This is the second probe. Oops. Oh no. Did I short something again? No. Eh? What's happening? It lost the thing. Oh, I maybe... Yeah. I just removed the cable. And this is what we... What? I'm confused. Is this probe right here? Oh, wait. Offset, no offset. Let's put it to 0. DC coupling, probe. Is this correct? 10 to 1. Somehow it's okay, it's Q. Yeah, it's grounded. All probes are grounded, I think. Yes, it is. Let's check what the autoscale does. Peak to peak. Second channel is, okay, you can see it, it's 1 volt. Okay. So this is now 2 volts per division on both. Now it's now it's both on 2 volts per division. I don't like this like strange overshoot. Can we change this? I can maybe change something in the code. Oh, ringing. Calibrate your probes. Okay, how do I calibrate my probes right now? I can calibrate them. Let's calibrate the probes. Shall we? So probe, this is ground. Demo 1, demo 2, how do I calibrate now? Probe comparison. Okay, yeah. Is this the first probe? Okay. Probe check passed. Make sure they are one times. No, that's our 10 times, I think. Yeah, 10 to 1, and they're set right. It's like I checked this because otherwise we would have like completely the probe. Okay, the first one check passed, and let's check the second one as well. I can try different probes if you want. Check passed. Both checks passed. We have to live with that. Okay, yeah, but let's take the first one here, this one, and check our outputs and the actual voltage that we get there. So we can do .500 volts per division trigger. Let me trigger that. Trigger. Ah! It's okay. Okay, now let's cursor. Okay, so we get how do I set it? Press the cursor key on the front panel. Cursor key. Manual. No. Not this. Not this. I want this and this. How do I set Y2? I want to set Y2. Yeah. Ah, yeah. No. How do I use the knob? What's the deal? No? No, that's not... Ah, come on. Okay, let me turn on touch. Can I touch now? No. You ignore the ringing, it looks pretty much like 700 millivolts. Yeah, but we got the problem that we don't get the maximum brightness. We should aim for 1 volt, I think. Because the brightness, if we compare it with the one where we didn't impedance match, drag the Y2 label. Okay, yeah, you can try. Yes! Ha! Ha! Magic! Woo! I put an affiliate link for the scope in the description. No. I don't know. Okay, it's not even 600 millivolts. For the win, yes, touchscreen. I really, this is one of the best things to have a scope with touchscreen. 200 ohms then. Yes, let's try 200 ohms. We can go with a little bit overdrive. Okay, let's not joke around. Guys, do you remember how I complained about my shoulder aching last time? The right one. I think I dislocated it in this during the night, because I was sleeping yesterday and I woke up in the night. I was sleeping on my right side because the left side was where I was vaccinated, and I was sleeping on my right side. I woke up and it made like a small jump, and I heard it like clicking in again, like it was like dislocated and maybe just popped in like plop, and my shoulder was like back in the socket. I don't know what happened. It was let's try 12,000 ohms. Oh no, okay, guys, please. Yeah, it was like really like. But today I was like working in the garden. It was okay. Okay, I grabbed some bread, and you guys, you vote on the right resistor to take. 200. I have maybe 200. I have 100, 300, 200, 150. No, I have 100. Ah, we will find some good resistors there. I get some bread for the fondue. Okay. I got some baguette. We can take some baguette bread and dip it. Oh, that's too cool. 220? $100? $10K. Oh, actually, that's a good idea. I just solder in a potentiometer and then use it to calibrate the brightness. But unfortunately, I would have to like use 3 at once. And we will just go with one value and stick to it. Breadboard. Oh, that's too hot. Okay. I take a look what we get. We have some resistor values over here. $200 it is. Okay, I have the values of 100, 150 and 200 ohms, and I have a reel of each in 1% precision, 0603. You can hear the sizzle. Okay, I turn this off again. This is so annoyingly loud. And this as well. Okay. Back to the scope, to the microscope. Oh, Christian, thanks for the calculation. So 200. Yeah. So are we going for the 900 millivolts or for rather 1 volt? Yeah, Michael, the problem with the potentiometer is that I need 3 potentiometers, otherwise, because we have 3 color channels, and then I have to adjust them all at once, and I don't want to short the 3 channels because that might be cause some problems and short them out in some cases. Okay, let's go with the 200 ohms. Another soldering. Didn't I say this will be a shorter stream? Okay, let's just fix that. See that we get a clean output and be done for today, and then next time coding session, hacker session, graphics. And Sienna, I hope you are there because you are the demo pro, so we can code some demos in 1-bit color. Okay, microscope. Blip, blip. But don't you think, Johnny, that it's good that the cheaper projectors are showing what the problem is, because it actually could damage other equipment or other displays, or it has to work on all of the we don't need that one anymore. It should really work on all of the displays, not only the good ones, especially if this ends up like being sold or something. Enhance. Okay, that's too enhanced. That's good enough. A little bit brighter, maybe. I hate the reflections from this ring camera, ring light. I need like from some light that's shining from the sides or something. I don't like how it looks on the camera. See, if we just shine from this direction, we don't get the stupid reflections. So this ring light, I don't know. I don't like it. I like it maybe for, oops. What happened? Did I break it? Uh-oh. No. Oh, yeah. Okay, it's just a power connector. If we shine like from the side, it looks much better. It's way better this way than from the front. Maybe I can use like the helping hand to hold it in place. Stupid ring lights. Maybe it's just this specific ring light that's causing this reflection from the direction. But I think that might be the case with the cable is so short, and they sent me like a British connector that I can use really here. I have like I have 2 different adapters to plug it into the power socket. Oh yeah, that that's what I'm talking about. Life hack. No, it's not the torch, it's still the ring light. I will quickly switch to the other camera so you can see what's happening. Here. I took off the ring light from the microscope. Usually it's it's here, and I just put it to the side, so the light is reflected in this direction, not if we shine from the top, it's reflected directly into the scope, the microscope. So this is way better now. And to show you the contraption here, they sent me, this is the adapter for the ring light, and I have another adapter. This is for oh, I can unplug it, but the camera is even worse. They have like the power brick for the camera. I'll show it. You can see in the center, maybe. That's like, I think this is American power brick. Then I have some American to British or something, and British to European. So it's like 2 adapters there for the power brick. Yeah, silly. Okay, let's get back to work. Not much fooling around here. Curly hair, yeah. I took a shower before the stream, but not washing my hair. It was like yesterday. Okay. Ooh, oh, that's so crisp. I love it. I will leave it like that. This temporary solution here. Oh, wow. Looking through the microscope, it's so good. Love it. Okay. Let's see if we can. But now I need the hot air gun. Otherwise we can't take it off. Oh, you don't see anything? Here. Here we go. Oh, wow. Yeah. We grab. Of course, they are all on the. They fell on the wrong side when I dropped. I think that it's too hot. It's 350 degrees. This is too hot. I'm melting all my connectors. Let's make it 320. Oh, nice. I think this actually, this is already good. I can really see much better now. what the difference the light can make. Oh wait. Okay, no. Crap. It's like the wrong angle for me. I need to rotate it. Sorry guys. Smearing everything around. Like full of solder here. Ah, what's this nasty hair? I don't know if you even can see it, but I need to concentrate right now. Okay, a little bit higher. It's gone. Oh man, the connector is completely molten because I have the hot air gun is way too hot right now. My resistor is sticking to the tweezers. Come on! It's like I need more pointy tweezers here. Let me grab some other tweezers. This is trash. I need some that are more better. You know? Too springy. I need really small, fine. That's not small at all. No. Give me better. I have a ton of tweezers here. This seems to work. I think we are good. Let me clean that mess. You want a close-up? Here is a close-up. More sharper? Here, more sharper. That's English. Yeah, that wasn't enough flux, I know. Okay, let's test it. That worked better than the soldering before. Ouch! Oh, this whole thing is so hot now. Okay. Oh, I'm still recording the stream. Oh no. I will regret this. Okay, I need to carefully connect the probe first, not to short everything. Here. We don't even need the red, green and the sync signals. I don't know why I soldered everything on. That was basically enough to see that we are off. Ouch, so hot. Okay. This is our new signal. Which is more like Casas. Oh. 840. So we are more like 840 here. Let me turn off this light again. There is no green. Let's turn on the other one and compare the brightness if it's still too dark. Otherwise we might need to go for the 150 or 100 ohms. Yeah. Fuck. Look. Ah! Damn it. Ah! Ah. Another round? Sorry. Sorry, Dave. No, you can see in the first row. Oh, wait a second. You can see it. Okay. So basically, yeah, focus. Focus. So in the first row, which is already brighter, you want the resistor code? Here. What? Ouch! Oh, I burnt my tongue. Ouch. Okay, in the first row we don't have the green yet. So if you compare it side by side, it's brighter already. The green increases row by row after that. So, oh, wait a second, there is one difference. They are not the same distance. Let's make it, no, it's still, but it's not much. I see a difference in brightness. Cheese on some butter. Let's butter up. Okay, let's try a solid block, okay? We do a solid block. This is the wrong one. Okay. Let's see if it's simply like the overdrive that bleeds into the next pixel, because we have like only half the pixels on. It might be that the overdrive of the signal bleeds into the... Oh yeah. Okay, that's it. That's it. Okay, Dave, the green only comes if we have like random pixels. So the code that I was showing until now, there was only every second pixel lit, and only then the green appeared. Now, when we have a solid block, there is no green. But also, what I thought now is that since we have this overdrive, it was overdriving into the consecutive pixels that is off, and that's why we saw it brighter than it actually was. And now it's matching, and that's what I wanted to see. I wanted the white to be similarly bright, and that's happening now, so I'm happy with the result. Let's stick to the 200 milliamps, and it's closer to the specs. No, it's not. It's 800. Yeah, it's more like 850 millivolts, but yeah, let's keep 200 ohms. It's not a software issue. Johnny. It's not a software issue. The level seems right, yeah. Let's keep no money. No money has to exchange the owners here. Let's check again if we don't get any greenish oddities on the new one, on the new connection, and then we have only to update. Yeah. Old one versus new one. New one no green, old one green. Ah, I'm using my hand now and burning my fingers. Okay. That picture might be really overwhelming if people tune in and see what's the deal there. But this is big. So impedance matching you guys really helped me with this issue. So it was actually overdriving issue, which the projectors didn't like, and now I only need to fix one complete board, every signal on the board, order new boards with the fixed signal, and we can implement a demo. Something that looks cool for a video. Man, the last video is already three weeks ago. I really don't know if I can pull off a quick video until Sunday now. But I'm happy that works already. Okay, let's turn this off. This was... Yeah. Oh, okay. Ah. Where's the face cam here? 6 sides asteroid is coming. There is no... Oh wait, we can do interactive stuff with the boards because we have actually a few inputs, but we don't have outputs. If we use like all VGAs, I put in a connector, and let me show it on the screen. Oh no, it's Arduino ID. Okay, we have all the analog, no, not the analog, the read-only pins broken out here, which we... Oh no! Okay, I admit it was a software issue. And I'm a genuine guy that never let him bribe with money. So all my opinions that I show are completely 100% genuine. Okay, we can admit there is probably a software inside of this projector which gets really confused by high analog values and tries to adjust the level of the green, so it's buggy. The software in the projector is obviously buggy. It should just normalize over all channels, but it doesn't. It's confused. Yeah, it's a software issue for 100% sure. Yeah, actually we could put on here a controller, but unfortunately not a Super Nintendo controller or something, because they need like a clock and a trigger, no, a latch and clock signal, and we have no outputs, but we could use like a touchpad thingy or something. No, this is not touch. It's like basic for yeah, we have, oh no, 34, yeah, we have 4 inputs pins that we can use the board with. BLE controller. Oh yes! You're right! I even have some here. I have really cool controllers here. I have a full box of controllers. That's not these. All the cables here. I have even some like super cheapo ones, but this is also Bluetooth. Bluetooth gamepad. That should work. I think that might work with ESP32. Oh, that's cool. Yeah. Oh, it's not inside. I took it out already. Use phone. Yeah, that's. Oh, I completely forgot that we have so many connectivities that are not wired. It's just a software issue. Thank you for the donation, Johnny. Okay, so we fixed everything, and next thing on the let's take a look at the this. Can we connect the tablet again? I will switch from the. Oh yeah, I still steal the input of the microscope to my grabber, so we can check the boxes here with our fancy. Does it work? Capture? No, doesn't work. Oh yeah, it's. Why is it? Oh yeah, that's good. Oh yeah, that's working much better. Okay. Okay, they're much better now. Cool. Okay, I turn this off. Where's my pen? Uh-oh. Where's my pen? I lost my pen. No. Here it is. Okay, different board wasn't necessary. Working channels wasn't necessary. Sync on green wasn't true. Oscillator check output green. We did it, and it was even handy to see that we got like the level below 0.7 volts. Now we are at 0.85 around. So like that. And resistor in series, we ended up using 200 ohms and to impedance match. So this was right. Pull down wasn't necessary since this is on the other side. So this was in the projector. And projector, we have 50 ohms there. Okay. Now, let me move this a little bit. And different displays, this was also showing. Okay, so this was our agenda for today. Next time, let's clear it. Discard it. Discard. Next time, demo. And you guys maybe think of something that we can quickly code to display, like some. Imagine if we have like, let's start with like this is the lab. Let's make it somewhat of a open perspective, and I can mount the projectors, let's say, and let me change the color. Okay. The projectors will project like on the walls, even maybe on the ceiling, and then we can maybe display some cool animations of waves like that. Imagine you sitting somewhere here. We can put them like on the ceiling. Maybe I will mount a bracket or something on the ceiling, so we have like we have some kind of setup all around, and we can project some cool stuff there. Maybe like a grid or something, wireframe that's animated and wavy. And what I was talking about last time is, imagine we project like a room. So we are inside of this room. Imagine this is projected on the walls. So we think we see like the corners of the room, but then all these corners and lines start to like tilt and spin around, and you inside of this room, you will go crazy because you think everything is like rotating and the whole room is tilting or something. Audio spectrometer. Yeah, but we don't have... Okay, we have no analog input. So we would need to... Google is reacting to my okay. We have no analog input. We either need to input the audio via web interface, UDP, or anything that will be maybe too extensive for now. We can do like... I want to see Dave Darko animated. What? Warp speed. Oh yes! Yes, Starfield simulation. That's even simpler. That's cool. Oh, I love it. Okay. We got some suggestions here already. Okay, Starfield. Starfield warp. So that was Dave Darko. Fondue boiling. I don't know how, but boiling. Yeah, UDP and make calculation on the other device. Yeah, that's what I would think. Spectrometer. Oops. Oh, I clicked the button. No, go back. Yeah. Spectrometer. What did we have? What else did we have? What app? Oh yeah, this is auto. No, this is how is it called? Oh no. This is an AutoCAD? No, not AutoCAD. What's the name? Oh, come on. What's the app name? It's free. And it's not Adobe. It's the other thing. Okay, let me check. Oh no, I shared everything my to-do. It's Autodesk Sketchbook. So this one here. Autodesk Sketchbook. It's cool. I can even turn off the only problem for animation on the video. I tried to use this for the animation, but the problem is if I lower the pen, maybe you can see it, the tip. If the tip is hovering, then I can rest my palm without moving the image. But I need to have the pen really close to the screen. Otherwise, if the pen isn't close and I lower my palm on the screen, you see it zoomed in, and now it's all around. I can't record like that because there is no reset zoom or anything. I don't know how to reset to the original size. So it's like I can't turn this off. I turned off rotation, but you can't turn off scaling. And that's why I can't use this, and I used another application for that, for recording. It was like, which one was it? It's my to-do list, yeah. I think it was whiteboard. No, it wasn't whiteboard. It wasn't whiteboard. It was a different one. Painter, maybe? Oh, I know. The one that I was using for the last video, this one here, I think that expired, or? So you can see this was from the last video. I did it I recorded it with the frame grabber on my PC because yeah, that otherwise I don't get a good quality. And here there is like, oh yeah, there is also the same problem with the scaling. Oh, now it's flipped. Oh, thanks, mate. Thanks. Now it's all is gone. All is lost here. But if I reload the image, it's like open, discard. Yeah. And then it's scaled again to the right side. Yeah, but that's always like the problem. I need to. Okay, I'm rambling now. Yeah, it's Samsung. The Autodesk stuff even has internal recording, but there is there's like there are times where you have here like this recording feature, and now I can draw something and save to device. Oh, I'm sharing now everything. Oh shit. Okay, yes, save. Oh no. I have the same issue with the palm zooming. Yeah, if you find an application that doesn't do that and have good features for drawing, then I would be very thankful. Scary pics? I don't know. I don't know what I shared there. I hope it wasn't something Chromebook. No, this is the Samsung S tablet S7 Plus. That's the current best thing. I wanted something that supports 120 frames per second and the pen. And it's OLED. So this is I don't buy like super crappy old school technology. I like OLED displays. That's why I got a good deal on that, because it was like a cashback, plus it was like discounted, and I think with the cashback, which already was paid back, I paid a total of 630 euros or something. So it wasn't very expensive compared to the Apple Tablet Pro whatever thing. iOS. Yeah. Please insert $100 to continue. I don't know. I didn't see any restrictions so far, so I don't know when these restrictions are coming. Okay, enough rambling, guys. I don't want to like. we have collected some ideas. If you can think about anything for the next time, let me show my face here. Oh, I love the camera quality. Woo! It's this is 1.4 f1.4 fixed zoom, no, like prime lens. It's cool. It's a Sigma lens. Really, I like the bokeh. Sion is up. Hey Sion, you just hit the end. Yeah, you did. So the gentleman helped to fix the problem with the board. That's you're right here for the conclusion. Maybe I will just take the board and show it around. We can disconnect everything. We have been debugging the board. If we get a focus, yeah, there are 3 resistors above the ESP. There are 3 resistors above the ESP32. If you can see it, I don't know if the quality is right for you. We soldered them on. We tested 330 ohms or 320 ohms or something like that. It was dim. I don't know, maybe it was the right resistance, but then we put on the oscilloscope. So basically the issue was overdriving the ADC. It was a software issue inside of the inside of the projector, a software issue where the ADC gets confused because we drive it with 3.3 volts instead of the 0.7 volts that it's expecting. So we did an impedance matching and got the output signal down to now with 200 ohms resistors in series, basically to 0.85, which gives us the actual brightness that the projector is capable of doing, and there are no green shimmering upcharging issues anymore. Yeah, the fondue isn't done yet, but this is for the next stream. We collected some ideas for this is the microscope. It's collected some ideas on the tablet for for the demo of this board, and this will be in the next stream. Yeah, that's hocus pocus for me. I'm a coder, so I only know digital stuff, and the word impedance already intimidates me so much that I basically just want to run away. Yeah, but I'm happy with the result, and yeah, thank you very much for everyone that helped and everyone else. I hope you enjoyed the stream, and thanks for joining. And I see you next time. I hope maybe this week already, maybe Saturday. I don't know what's tomorrow is Friday. Give me one day to prepare something, and I think Saturday is a good day to stream again. So see you hopefully on Saturday, and I see you next time. Bye. And now let me search awkwardly long for the button where I turn off the stream. Oh, outro. Oh yeah, yeah. Outro music. No, this is waiting. Waiting game. Okay. Yeah, touchscreen. Ah, guys, it was a blast. I'm really happy everything worked out so well, and also we got like the lighting in my microscope so much better.